Thank you. Good morning. I am from the dark side. And those of you who've seen my tag this year is "Come to the dark side, we have cookies." I had cookies, but they're all gone, so the new tag has come quickly because the cookies run out fast. Okay. So I'm the fool that decided to do a file system talk at Linux.conf.au, which was a bad idea. This is this is not an internals discussion of btrfs. Okay, for that, I can point you at some lovely, very, very in-depth presentations that Chris Mason and Jan Schmidt have done on how the stuff actually works on disk, or doesn't. This is a beginner's tour to why btrfs is shiny and why you should start looking at using it. Okay. So, hopefully that's kind of what you were understanding. If not, you can come back for the XFS talk, which is where I'll be next as well. Right, so what is btrfs? It was originally developed by Chris Mason at Oracle and then now jointly developed by a whole bunch of people. Oracle, Red Hat, Fujitsu, Intel, SUSE, and more. Those of you who follow the btrfs list, hang on a sec. That's good. Yes, no, they show up when it's the next slide. They don't show up when it's the current slide. Awesome. Let's do that and see if they do. That's better. Okay. I am using PowerPoint. Unfortunate corporate template styles. Okay, so those of you who follow the btrfs list, Chris just pushed a pull request to Linus this morning from a whole bunch of stuff out of Fujitsu with the new RAID rebalancing code, which I'll get to in a couple of slides' time. The key of btrfs is that all data and metadata is copy on write. Okay, so we never go and overwrite data on disk. If you've got a file and you want to change it, we read the file and then we write it out, not the file, we write out blocks that are changed. Okay, so we don't ever actually go and change blocks on disks. We just copy them and write them out and write out the copies. We maintain CRCs for all metadata and data. Okay, so everything is checksummed. So we can tell when the data has gone pear-shaped. And until recently, we could tell you when the data has gone pear-shaped, but we couldn't do anything about it. We could just say, oh, look, your data's gone pear-shaped. Now we can do something about it, okay? And one of the demos, I'm not going to spend a lot of time talking. I'm going to spend more time actually showing you btrfs, so I'm going to kind of run through the overviews fairly quickly. Efficient writable snapshots, snapshots of snapshots, snapshots of snapshots of snapshots, and sub-volume. So btrfs includes not LVM-style volume management. It doesn't create block devices. It just creates sub-volumes inside the file system, and you can mount sub-volumes, and we do some fun trickery in the last demo, which I added this morning. So you'll forgive me if that one doesn't actually work. But we do some really interesting things with mounting sub-volumes. Multi-device support built in, because what Linux really needed was another implementation of RAID. We have built-in RAID support. So at the moment, we have RAID 0, RAID 1, RAID 10, RAIDs 5 and 6, and triple mirroring is in Chris's to-merge queue after he releases btrfs check. Online resizing and defragmentation. And in fact, you can online size up and size down. So you can remove devices in and out of a btrfs file system while it's online. You can also now replace devices while btrfs is online. So you can add a new disk and you can say rebalance, and btrfs will move extents across to the new disk, and then you can drop the old disk out of a btrfs array. We have transparent compression, and we do that per file basis as well. And we back out if the file won't compress, so we just write it out. Efficient storage for small files, so we pack the files into the metadata as well. And lots of SSD optimizations, which, by the way, SSD optimizations aren't. They're just turning off all the optimizations we do for rotational media. Okay, so we just say, oh, no, look. And trim support now as well. So what are we working on at the moment? Extensive performance and stability fixes. I spoke to Chris this morning. And he said, yeah, that stability thing was very important because his pull request for 3.3 wouldn't allow you to boot a system at all. So that was a really good one. Okay, so that's now been fixed. If those of you who are looking for a very special announcement today are not going to get it because he was fixing the 3.3 pull request, a lot of code cleanup. So I'm moving around a lot for the video, I just realized. Finally, some free space caching across reboots. So we actually cache the free space map. Delayed metadata insertion and deletion for those of you who still do have spinning disk. Background scrubbing, and that becomes very important once you get into RAID 1 and RAID 10, and we look at what scrubbing is and why that's very cool. LZO compression is in mainline. Snappy compression is coming in development, so it's in the pull windows. So the difference, pretty much as I understand it, between Snappy and LZO, the resulting compression levels are about the same. Snappy is just faster at determining whether the blocks can be compressed or not. Okay. So basically what btrfs does is it says, can I compress this? Yes, okay, I will compress and write. If not, I will just write it out uncompressed. Okay, so it doesn't waste time trying to compress it. Batch discard, so we have live discarding, so -o discard for SSDs, so it'll do trim discarding on the fly, or you can turn that off and batch discard. Most SSDs that do this don't need it, but it's very nifty for the embedded devices that have less than stellar flash in them. Per inode flags to control copy on write and compression. So you can actually flag files to not enable copy on write or not be compressed. And automatic file defrag. I think I just said that actually somewhere. Okay. One of the upcoming changes, we use key ordering to group blocks for metadata. The problem is at the moment we're sitting at a 4K block for btrfs. That's in the 3.2 Linux kernel. And we're pushing about 78 megabytes per second. Once we push up to very, very large blocks, 16K, so 4 times the size, 186 megabytes per second, okay, for metadata writes. So the bigger the block, the less fragmented our B-tree metadata blocks are, so less overhead because everything gets copied on write. So we just write all this stuff out much quicker. Okay, so that code, basically what's going to happen is we're going to allow you to create bigger blocks in 3.3. The default will still be 4 though. And then based on testing results from the 3.3 merge, Chris is looking to in fact change the default from 4 to 16 later on. Okay, but at the current one, when you get 3.3, you can create bigger blocks. Later, we may automatically create bigger blocks.
But it is one block size per file system.
Pardon me?
One block size per file system, right? So
yes. Yes. Okay. Here's where we start the fun bits. CRCs allow us to verify data stored on disk. So we check some metadata and data, which means we can correct by reading a good copy of the block from another drive. Okay. So the new scrubbing code now scans on read automatically. So if you're in RAID 1 or RAID 10, we're automatically doing checksum validation. And if the checksum fails on the first read, we'll pull it off another copy. Or we recommend, so those of you who have enterprise SAN devices, those enterprise SAN devices scrub on a regular basis. Because what you don't want, you know, everybody says, oh, if you've got scrubbing on read, that's great. I'll never worry about this. The problem is btrfs is deterministic as to which copy it reads normally. So if you've got a RAID 1 array, you've got 2 copies of every block, metadata and data, it's always going to read block A off 1 copy. And if that copy always remains good, it's always going to read that copy, it's never going to scrub. If the disk on which that copy fails, and now you're left with disk 2, and that one's gone bad, and you haven't been scrubbing, you're now left in a position where the checksum will fail, and you can't read the data. So we recommend that you scrub. Chris is sort of saying very, very high usage file systems once a week, not so great file systems once a month. I would scrub once, see how long it takes, and then adjust accordingly. It does, thankfully, scrub in the background. So you can start a scrub and ionize the scrubs down so they don't impact your performance, and then just work out how long a scrub is going to take, and then schedule a scrub to happen in the points of low utilization of your file system. Okay, so it will be extended to track and offline bad devices. Something to note, though, btrfs's RAID is not what we think of as sort of MD RAID. It's not block RAID. Okay, it's not mirroring block devices. It's just ensuring that for every block we have X amount of copies. So at the moment for RAID 1, it means that we have 2 copies. But we can have devices of different sizes inside a RAID 1 array. So you can create a RAID 1 array of 5 devices. All btrfs will do is ensure that for every block we have at least 2 copies on 2 different devices. Okay. RAID 10 is, obviously we need mirrored pairs, so the stripe of RAID 1s. So, let's give this a whirl. Can we all see? Yep. Okay, so this is my lovely Oracle Linux 6.2 running our brand new Unbreakable Enterprise kernel 2, release 2, which is currently in beta, which you can download. So public-yum.oracle.com/beta. You can grab the kernel and btrfs progs if you want to play with btrfs. This is pretty much the version that will go into production with Oracle Linux 6 later this year. So we are taking btrfs into production. When we release this kernel, we will also be releasing an update to the Oracle Linux 6 installer that actually allows you to install with a btrfs root file system. Okay, so you will be able to run btrfs on root for reasons which in my last demo should become obvious if my last demo works. Okay, so the one step that I always forget, because this is a brand new, I keep resetting my snapshot and I forget that I haven't actually turned on btrfs. So turn on btrfs, I'm going to make a fs. Yeah. It's production ready pretty much, yes. I'm not production ready, but the file system's fine. Okay. SDBNC. The one cool thing about btrfs, it doesn't matter how big your disks are. Make btrfs is that fast all the time, because we don't actually write anything. Okay, there's a small, tiny little block, and that's it. I've just created a RAID 1. So I have metadata is RAID 1, data is RAID 1 on devices SDBNC. You can see currently we're at 4K blocks, 16 gigs total, because it's 2. And here's where size becomes really interesting with btrfs, because it's 2 8-gig drives. And it's telling me it's 16 gigs total. But it's not, because it's RAID 1. I can only fit 8 gigs worth of data on here. And in fact, it's less because I need space for metadata as well. So there's data space. And this is why df-h lies to you. Okay? Never trust a df-h with btrfs. We actually have, if I can remember the command for that, file system df. So let me mount this. Btrfs, mount. And the cool thing, I just have to mount I just have to reference the first device in the array, and it'll just mount the whole thing for me. So adding and removing devices from the array is really simple. I don't have to worry about MD devices, what I'm referring to. And you can in fact refer to any of the devices in the array. It doesn't matter which one.
Show us proc mounts now.
The DevSDB mounted on btrfs.
It doesn't say the second device?
Correct. No, it doesn't.
Where do you
Yes, you can. You can do it by label. You can do it by UUID. You should. The nifty thing is that if you have old FS tabs that refer to DevSDB, that will continue to work regardless of how many more devices you add and remove, assuming DevSDB remains in the array.
Expand on Bruce's question. Since SDBC is not in proc mounts, what happens if you try and mount something else on SDBC?
Fun. No, it'll. It should say it's in use. Actually, I haven't tested that one. Okay. No, shush. I've got so little time. Come on. Okay. So I mounted there. I'm just going to copy in some. Okay, so there's my boot kernel. Woo.
What does DF show at this stage?
Oh, df-h shows that I'm using 56K. Awesome. Yes, and it says 16 gigs available, whereas I don't actually have 16 gigs available. Also because I haven't synced. So now it does actually show that I've got 8.1 megs, but still 16 gigs, which is kind of a lie. So if I do btrfs, btrfs, file system, df, btrfs. So you can see data in RAID 1, I'm using total 1 gig allocated, because we allocated in 1 gig chunks so far. It's only allocated a 1 gig chunk of RAID 1 so far. Remember, it's not actually RAID 1ing the entire device yet. I can have different RAID levels for files on a btrfs file system. I can say some files are in fact not RAID 1. I can turn off their RAID. Currently using 3.98 megs. Data, in total 8 megs on the disk. System RAID 1, total of 8 megs allocated, used all of 4K. Metadata is allocated a gig as well. I've used 24K of it. So that's kind of fun. Okay. So now what I'm going to do, because I have copies, and I'll just sync a few times again. Let's take a look at file. There we go. So this is sitting physical block 269312. It's a 4K block. So 496 times 269312. That's what I want to corrupt. We have a very, very, very lovely, dangerous tool. So one of the things that you should be very careful of with btrfs corrupt block, its default is to corrupt all the copies of the block. So we do want to do the first copy. And do that. Whoops. I need to use my divstb. There you go.
Well, you can't do online corruption?
Not on purpose. Okay. So what I've basically done, I have corrupted the first copy of that block. And now I'm going to remount divstb at, and I'm going to sum. So one of two things is going to happen here. Either it's going to auto-scribe or it's not going to auto-scribe, because I don't know which copy it's going to try and use when I sum VM Linux. So in DMSG, there we go, it auto-scrubbed. So checksum failed in that block. It automatically corrected it, and then copied on writed the working block back from the copy. So this is not very useful. So now what I need to do is, in fact, umount and go back and actually kill the second copy, because that's the copy that btrfs is reading from. So now I've corrupted the second copy. I can mount. I can sum, and this is where things get really interesting. This is why scrubbing is really important. The sum is the same. So btrfs hasn't actually detected the on-disk corruption yet. So what I really need to do, and this is why file system scrub, no, file btrfs scrub start btrfs. It starts the scrub. I can do a status of it. And it has scrubbed out with 0 errors. Why didn't you fix my error for me? Because it probably went and error and fixed my read error again. So we're very good at fixing. The nice thing is, but this obviously only works with RAID 1 or higher. You need to have another copy of the block somewhere. You know, if you only have a single disk btrfs scrub, it will alert you that there's something wrong, because it still checksums even on a single disk or in RAID 0, but it has nothing to copy from. So it has no known good. Okay. So there we go. So that's scrubbing. Awesome. So we now have discard and trim. So anybody here not know what discard and trim is?
It's for SSDs.
It's for SSDs. It's basically to tell the SSD we're done with the block. Okay, essentially, it's an optimization for SSDs. So SSD's internal copy on write load leveling kind of mechanism can say I can just write over that entire block without worrying about what might be there. We do it both real-time and batched. So the default, if you mount discard, is real-time. We'll actually send discards down to the SSDs. Or you can turn it off, and you can do it via an IOCTL, which is coming, that you can do a batch trim to all the free space. Drive swapping. So we can now do, as a Google Summer of Code project, the RAID rebuild works via the rebalance code. So one of the nifty things is you've got you can restripe between RAID levels soon, but you can add devices to btrfs at any time. And then you can start rebalancing btrfs. So you can tell it, here are 2 disks, they're RAID 1. I can then add 2 more disks, change it to RAID 10, tell it to rebalance, and it starts making sure that we've got copies across and starts striping across that RAID 10 array. So the restriping between RAID levels actually does it via the rebalance code. Okay, so it basically just rebalances. Because again, this is not block level RAID. This is not block device level RAID. This is data block level RAID. Drive swapping, in-place drive swapping. Okay, so I just shove a new disk into my device, and I tell it, OK, move from one device to another. We are currently working on, and this is my lovely friends over in the Solaris department at Big Evil, tell me that ZFS send and receive is the best thing since sliced cheese. It makes replication of ZFS volumes really, really easy. btrfs send and receive is in development. It actually works now. So there is a working version of btrfs send and receive on Jan Schmidt's Git repo, which I couldn't find when I was writing the slide last night. And it transmits in neutral. So it actually transmits, it doesn't transmit the original block. It's transmitting in neutral. So we hopefully do not transmit the corruption. btrfs is friendly fairly to small machines, unlike ZFS, particularly ZFS's deduplication mechanisms, which requires lots and lots of RAM. It's not as friendly to small disks, though. As you saw with that file system DF, btrfs went out and allocated a gig of data and a gig of metadata. The first time I wrote it, 8 megabytes to the file system. So in that, for my 8 gigabyte virtual disks in this virtual box, I'm probably going to be able to fit 7 gigs worth of data and a gig of metadata. Because I probably won't need more than a gig of metadata for 7 gigs worth of real data. One hopes. Depends on how often I actually, again, this is all copy on write. So it depends on how much change goes onto these things. Chris has a, and I point you to his fun tools location in a sec, but he has one of the things that emulates a kernel compile, the file system activity of a kernel compile without actually doing a kernel compile. Which takes, so we're not doing CPU testing, we just want to see what the file system does. And there's some really interesting things. If you keep writing data over and over again, you might need more metadata and land up to a point where you've got 2 gigs of metadata allocated and 6 gigs free kind of thing. Okay. But it works very well on low-end flash because we can do SSD optimizations inside btrfs instead of sort of relying on Flash's own load leveling capabilities. The copy on write nature of btrfs is load leveling. Okay, because as you'll see in a really fun animation when I create 1 billion 0-byte files, you can actually see that load level in operation. Okay, so the RAID 5 and 6 code was implemented by Intel some time ago. It is merged pending the file system check work. It adds triple mirroring, so the equivalent of RAID Z, if you like. Okay, so RAID 6 triple mirroring. What's really cool is mixed RAID modes for metadata and data. So you can have data rated at RAID 10, but metadata at RAID 1. Or data at RAID 6, metadata at RAID 10. You know, so you can start mixing your RAID modes on a single btrfs volume, which is really nifty. This is the fun one. Right. I would really love for all of us just to hide quickly. That'd be awesome. Okay. So, when bad things happen to good data. Okay, so btrfs about, and still has some bad flag for when things go bad, they go terribly, terribly bad. There is currently a read-only recovery tool from Joseph. This basically attempts to get all the data off a btrfs file system and copy it somewhere else. It's read-only. It doesn't touch the existing btrfs file system. So you need another file system to which you can copy that data. And that actually works really well. Okay. We have now the tree root history to recover from a lot of hardware errors. Okay, because of course btrfs is copy on write. So we'll just walk back through the root history and we'll find a known good copy of that and mount that. Okay? A new file system check release is on the way. I spoke to Chris this morning. The only thing I can say about this is he is talking about btrfs in LA on Saturday.
Very
okay.
subtle.
Very subtle, yeah, very subtle, Mrs. Esterhausen. The current recovery beta tools are at that Git repo for Chris's set. That's the read-only recovery, and I will now show you a full file system recovery, which is kind of fun. I assume when btrfs check gets released, it'll be in btrfs progs as well. The other indicator about the release of btrfs check is that Oracle has publicly stated at Open World last year that we are taking btrfs into production with the release of our new Unbreakable Enterprise kernel. That release has already gone into feature freeze in the kernel. Okay, so the kernel has feature frozen. Btrfs progs, Chris uses this as an excuse for not delivering because Btrfs progs is not technically in the kernel. So the feature freeze didn't apply to him. Okay. The indicators of this as to sort of time frames, we released a TPC benchmark with that kernel in, I think, late November, early December last year. And TPC benchmarks are only valid 6 months from the release of the benchmark. So my usual joke of when is Oracle going to release a product, it's between now and the heat death of the universe. We have a 6-month window from the release of that TPC benchmark to get the kernel out because we did the benchmark. We audited TPC benchmark on that kernel. For those of you who are following, because who doesn't follow me on Twitter?
Sorry, what's TPC?
TPC, Transaction Processing Council. It's a database benchmark. Okay, so last year Oracle, with our partners Cisco, we published a TPC benchmark on a single server of 1.2 million transactions per minute. And this morning, because it just got announced by Yahoo and News and everybody else, but TPC's website hasn't actually been updated yet, we announced our new non-clustered TPC result on a single Sun 4800 box of 4.8 million transactions per minute. Okay, so on a single Intel box, the only 2 devices that can beat us is the IBM Power 7 and the Bulla Scala Power 7, which is the same thing with a different case. Okay, so 2 big Power 7 mainframes and a 5RU Sun 4800, which is pretty awesome. And that one was only waiting for the fact that that benchmark uses 4 terabytes of RAM, and we had to wait for the Sun guys to actually put the the ability to buy 4 terabytes, because you have to be able to buy the system when you publish a TPC benchmark. You have to be able to buy the system. So we had to wait for them to put that on the price list so you could actually buy a system with 4 terabytes of RAM. Okay, so let's have a look at file system recovery. What happens when everything goes pear-shaped? Okay, so what I'm going to do is mount btrfs again. I'm going to use something called debug tree -r. Oops, no. So what this is showing me, the extent and device file system and checksum trees, this is where their current points are on the file system. And now you can start seeing the rolling backups. So there's my root backup, that's Gen 13. There's Gen 14, okay? Gen 15 and Gen 16. They're actually in order, but that's a rolling backup. Okay, so every 30 seconds, btrfs creates a backup. So I have 2 minutes worth of known good rollback point at this juncture, because it's just going to keep rolling these things.
Sorry to interrupt
Correct. Yes. It's going to continuously do this at 30 seconds and just roll. Even if it doesn't change the blocks, it's just going to roll the generation. Okay, this makes fsync faster as well. One of the things that we did is we changed the way the metadata logs happen. Fujitsu did, in fact, change the way metadata, and it sped up fsync on individual files by like 75% or something, which is really cool. Okay, so what I'm going to do...
So does that mean that the drives are continuously kept busy even when you're not doing anything?
Yes. Yes, every 30 seconds at any rate, yes. You can turn this off, though. You can disable it as a runtime. It's possible for a bit of it to get corrupted, but the likelihood of all of it getting corrupted, again, because this is copy on write, so I never overwrite any of this. I'm just writing it somewhere else on the...
So there's not just a block somewhere?
No. But what I am going to do is I'm going to take the checksum key, which is sitting over there, and I'm going to... Who's the local source? Corrupt block. It's already unmounted. Now, I've corrupted that on both copies. If I try to mount now...
But corruption usually happens when the system is online, not when it is offline. Right?
Well, yeah, but you've got the corruption scrubbing, the likelihood of corruption happening...
It's usually when the system is running.
Yeah. Hopefully the live scrubbing should take care of that, because we'll just copy off a known good. So run red 1 arrays.
What made it touch SR0 in the middle?
Because of VirtualBox. That's just VirtualBox is trying to create a the virtual CD-ROM device.
Okay.
There we go. Ooh, crappo. If I look at DMSG, there's my bad tree. It says, oh, I couldn't open the checksum tree. I'm just failing. What do I do? How do I recover? It's really easy. Done. So it read the bad trees. It's still mounted, because now what it's done, there's my lovely file. For those of you who remember. Anybody remember numbers? Because those were the numbers. Yep. It basically has done, I need to U-mount btrfs, because btrfs debug tree -r devsdb, it's rolled that checksum tree back to, you can see this is now Gen 17 and Gen 18. We were 15, 16. We're now 17 and 18 because it's gone on. But if I go lower down, you can see there's 15 and 16. So 15, 16, we've rolled to 17 and 18. We've actually rolled, I think at that stage, we rolled back to 17. So your worst case scenario is you've lost 30 seconds of data changes. Again, this is copy on write. So what we've done is we've pulled the system back to 30 seconds ago. Okay. If that was also corrupt, we would try the next backup, and the next one, and the next one. The likelihood of none of them working is why we need btrfs check. Okay, I'm getting the 10-minute mark, and here's the last demo that I really want to do. So that's the recovery as it stands. Billions of files. This is just showing off some write-back and metadata bottlenecks. X4 and XFS tended to get stuck behind their locks. XFS has dramatically improved here, and the next talk will show that improvement. We know that there's a current write-back regression. We are working on it. One of the 3.3 merge changes was to solve that, but that's kind of what the file creation benchmark looks like on SSD for btrfs, on spinners for btrfs. What I will show you, because the I/O animations for this are pretty cool, actually. So this is... Let's just do, where's F11? There, no. Come back. Come back. Ooh, full screen. Okay. So this is what ext4 looks like when it creates 1 billion files. You see the really busy part? Okay, it's doing 30 megabytes a second. Okay. And it's pretty much bottlenecked on its journals. Okay, that's essentially just where ext4 sits. XFS is nifty. This is XFS doing the same thing. But it has this most amazing pattern. The green is read, so the green is write, the red is read. But it is still, at this point when we did this animation, stuck behind the log. That's gotten much better. But you can see what happens with the seeks per second. And if you want to see load leveling, so let me just go back there. Whoops. Stop. Stop. So let's go back to btrfs. This is what load leveling looks like. So that's the copy on write of the metadata happening. Okay, so btrfs is just load leveling a billion files worth of metadata across the disk. Okay, so it's sustaining, upwards of 100 megabytes per second, and this is on a 4K block. We reckon on a 16K block we'll get 200 and something megabytes per second, which is kind of nifty. If you want to know how those animations were created, it's part of Chris's fun tool bucket, so it's called SeekWatcher. It basically takes the block trace and it creates animations out of block trace. Okay. But it gets me to my last demo, which is converting root to btrfs and the glory that is yum plugin fs snapshot. So yum plugin fs snapshot already exists. Basically what it does is it snapshots the file system prior to doing a yum upgrade. Okay, and the only file system that currently supports snapshots is btrfs. So what we're going to do, unfortunately, our installer doesn't support btrfs as part of the installer. So the simplest way to convert a file system, obviously we convert in place. We can convert X3 and X4 file systems to btrfs. What we do is we store all that ext2 data as a snapshot, so you can roll back to where you were before you did the convert. But what we will do is, come back. There we go. Okay.
You mean you can roll btrfs back to X4?
Yes, or X3. At the point where you converted it. So if you've got an X3 or X4 system, you can convert it to btrfs. You can run with btrfs, and if you don't like it, you can just tell btrfs to go back to where you were before you started. Because we store the X2, X3 as a snapshot of btrfs. So the easiest way at the moment to convert to btrfs is to boot the Fedora 16 Live CD, which has btrfs inside the installer and has btrfs convert. So here's how you convert this stuff as it chugs away. This is my quick plug for Oracle VM VirtualBox for all your free desktop virtualization needs. My dismay at GNOME 3. This is why I now no longer load the VirtualBox guest editions on Fedora, because then I'm always assured that GNOME 3 will never run. It's great. Okay.
That's a trick. I'll have to learn that one.
So let's become root. I've got my logical volumes. You can see there's my LV root. So what I'm going to do is btrfs convert dev vgol6 LV root. And it goes and creates the btrfs metadata for me, and at that same time it's taking and creating a snapshot of the X2 system, because it doesn't actually snapshot the journal. So it creates a copy of the X2 data. So that's it, it's just converted my system. And the thing that I always forget, which hopefully I will now remember, I need to make the root mount div, because what have I not done yet? On root, vi root etcfs tab. Where did I go? There we go. That's all I needed to do. I actually need to pull the CD out of this machine, remove disk. Some mount, that'll do. Okay, so there we go. We boot into There we go. And it remounted root. Yes, I did it right. Okay, so let me go back to my terminal. So now if I look at mount, root is mounted btrfs. If I look at the subvolumes, btrfs subvol list, you can see there's the ex2, the saved ex2 subvolume. So I can always go back to the point at which I converted. Okay. So now what I'm going to do, because let me just make sure that I actually in this copy have fs snapshot installed, which I don't. cd var www.html yum ml6 latest. Oops. Thank you. So yum group install. I'm going to do something very silly. Yeah, it does. There we go.
The internet here is good.
No, I actually have Yum on the same VM. So there you go. It's snapshotted. I don't know if you saw. There's the snapshot happening. It snapshotted both of my btrfs file systems because, in fact, the Yum repository is also on btrfs. So it snapshotted root and btrfs. So now it's chugging away, installing a whole bunch of stuff. I was going to do this demo by installing a whole bunch of CentOS RPMs. But there's a conflict between, because I'm using the new kernel for this, and CentOS doesn't have that kernel, there was an interesting conflict. So while that chugs along doing Yum stuff, any more questions?
Running an F-based system on btrfs has been, currently is, I guess, with this new code, appallingly inefficient because of the syncs that the get upgrade does.
Yes.
Is that fixed by the
Yeah, I believe the new metadata logging that Fujitsu's made fsync about 75% faster. Certainly, I mean, this Yum, which does similar things, is much, much faster running on btrfs. And it's actually running btrfs for both the location of the Apache's Yum repositories and writing into root. So it's much better at it. OK, so there we're done. So now we've installed what I'm going to do. btrfs, btrfs, subvol, list that. There's the second, so it's ID 257. Just so it's easier than me having to type. Before X.
We'll turn around in a minute.
Yeah, give me 2 seconds because this is cool. Root flags equals subvol ID equals 257. It was 257, wasn't it? Yes. OK, so now I reboot. So it reboots. There goes VirtualBox. It chugs away. I didn't change init tab to init 5 by default, but that's OK. There it goes, and it starts firing off first boot because I didn't actually run that before. Because first boot is not installed in minimal, and I could start X. And X comes up, and we're running as root, and oh, that's not really what I wanted to do to my server. So if I restart, come on. Before X, something to notice in the top left-hand corner, it's mounted subvol ID 257. X isn't even there. It's gone. I now obviously have to give my firstborn child to the god of demos because that actually worked. But So yeah, so that rollback is very, very nifty. So you can snapshot at any time.
I don't like how this keeps going off. We do have enough time for one or two more questions. There's a lot of hands up there.
I can't read that from here, you're joking. And you've just erased it.
I'll take two. I saw this hand first. I'm going to randomly pick the hand, that one there in the green shirt. We did have questions during the talk, so we're only going to have a couple of questions after the talk. So, fire away. Thank you.
Who was the first? Hang on.
Hi, so if you have software RAID up, of course, you shouldn't be using it anymore. In your case, since you have checksums, if one drive is returning a bad block, I take it you can detect that and rewrite the block,
correct?
Right? Okay.
Yes.
And outside of having checksums and knowing which one or two drives is wrong, which software RAID doesn't do you have other benefits from doing RAID directly in the file system?
Because we can rebalance that at any time now. So you're not stuck at any RAID level. We can start with RAID 0, make it RAID 1, then rebalance, and btrfs will go and replicate it. The goal eventually is to not duplicate the RAID code. As in fact, Chris has said it's silly that Linux now has 3 RAID implementations in various places. But the way it's done now, it makes more sense to be in btrfs, and hopefully over time there'll be one libraid somewhere, potentially. But that's not on our roadmap.
And if you're using software RAID, you should just basically start over from scratch, right? You
can do btrfs on software RAID.
Yeah, but you just don't want to, because your code is better than software RAID for that.
You don't get it. It depends on what you want to achieve, essentially. In fact, I know a lot of people who have software RAID 1s and then do a btrfs RAID 10 on software RAID 1s kind of thing and use both balancing codes and, wow, let it all work. It's all kind of fun.
All right, thanks.
So, yes. There was a green there. Dedupe. Technically possible. Okay, I mean, it's one of those things that we know that the code can do it. It's on a roadmap, but it's not something that we find particularly interesting right now. Disks are so large that it's cheaper in terms of processing power just to buy more disks, which are very cheap, than to work with CPU processing to work out that I'm deduplicating, because this is all copied on write. So one of the challenges I now have to compare against, what am I comparing against? The stuff that I've just written, everything else on the disk, and that becomes very interesting from a CPU point of view. When ZFS does it, for example, they say don't turn it on unless you've got like 4 to 6 gigs of RAM to hold nice big dedupe caches and stuff. So, yeah. So, cool. But you can obviously come and find me if you have more questions about btrfs. If you want to test this, obviously Oracle Linux 6.2 is free to download, and all of the kernels and btrfs progs are free to download. So, or it's in Fedora 16 now as well. But Fedora 16 doesn't have the latest. So we've actually merged in all the 3.2 changes, not the 3.3 change, but all the 3.2 mainline changes are in fact in our kernel as well. So all of that metadata improvements and stuff is there as well. Cool.
Thank you very much for that talk, Avi.
Thank you, guys.
A very popular subject, and one which, of course, as you said, you will also like answer a few questions if people want to collar him afterwards. We do have a small token of appreciation, a glass penguin plated in gold from Ballarat. Thank you very much.